Hello, welcome to this tutorial on the Technology Velocity Index. My name is Daryl Kleinke, and my goal today is to get you started on the assignment for plotting your first velocity index. The Technology Velocity Index, just a reminder here, is that it's the way to compare the rate of an organization's adoption of technology to the industry's rate of adoption of technology. We're interested to see where we believe the industry is at any point in time in terms of maturity of the technology versus where our company or our organization or our department or even us as an individual happen to be in terms of our understanding and application and implementation of any given technology. This is important because we want to understand where we are at a point in time, where is industry, and how far along are we? Are we trailing? Are we at the cutting edge? And more importantly, is this term we're calling velocity. This is the rate of change of maturity. And are we catching up or is industry pulling away? So, our goal is to identify, again, where we are in terms of understanding and implementation of the technology compared to the industry norm. So, how does this work? We've identified 5 stages of technological maturity. And those of you that are familiar with stage gate planning might recognize these as various gates, we'll call them. And as the maturity of the technology develops, we've identified 5 different gates, if you will. And here they are. The new infancy level, this is a stage where the technology maybe only appears in patents searches or very early on. Or stage 2, it's rapidly evolving. It's gone from the point of infant technology to we're starting to see more and more applications out there. Stage 3, stability is emerging. We're not only seeing instances of it, but it's been commercialized. We start to see it show up in perhaps commercial products or services. Some of our customers or our competitors are beginning to implement it. Stage 4 then is widely implemented. Pretty common to find this technology on a plant floor, maybe embedded in a product, might be used by our customers or our suppliers. And then stage 5, we've gotten to the point where the technology is pretty much accepted as standard practice. Perhaps I'll give an example here of LED lighting. Back in the early 60s is actually when LED lighting was first invented. That would be the new infancy stage. Approximately along the mid 90s, approaching the 2000s, we started to see stability emerging. We started to see more and more applications of LED lights. We find competitors in the marketplace who are proposing better versions, cheaper versions, more efficient versions. And now we are approaching the very mature level of LED lighting. In fact, we've gotten to the point where LEDs may actually be displacing incandescent light bulbs as the standard way of lighting. So this is an example of a particular technology that's moved across these 5 stages. Your assignment then is to place the industry, whatever technology you're looking at, place the industry on the axis. In this case, we might show the industry average somewhere between stability emerging and widely implemented. And then put your organization on that same chart. Are you on the cutting edge? Are you about even with the industry average? Are you behind? Show your organization or company or individual and where you stand relative to the industry average. Secondly, we ask you to use an arrow to show how fast you believe the technology is emerging, both on the industry level and the local level, your organization. Notice this case illustrated here. If this were true, industry is actually pulling away from your organization, moving faster than you are developing and implementing that technology in your company. Then finally, based on the gap between the industry and your organization, identify the key skills of the workforce that you'll need to close that gap. Here's an example of emerging technology regarding electric vehicle batteries from the automotive industry. If you were to make a velocity index plot, you might place the battery technology in all industries near the widely implemented stage. on average. Now, this would include battery technologies in all fields, commercial products, could be the power industry, could be medical professions, could be aerospace, or a combination of any of those above. So that would be the technology in all industries. And then you would place the average of where you believe, suppose you're an automotive manufacturer, where you believe the technology is in your particular application. Drawing the arrows would indicate that you, in this case, you might believe the technology in all industries is moving faster than you are advancing the technology in your application for vehicles. And so we would take a look at what kinds of skills or workforce development we would need to close that gap. Okay, so that was a little overview of your assignment. We just want to give you a few tips here that might help you out. Tip number one, this is a team sport. In order for the technical velocity index to be most effective, it helps if technical and business people work together. If only technology people talk to technology people, there's some interesting conversations there, of course, about the development of the technology itself, might be details of the physics associated with the technology, and so on, but probably very little conversation about implementation, cost, return on investment. On the other hand, if business people only talk to business people, there might be lots of discussion about return on investment, implementation, marketing, but not watching the next technical breakthrough, which may make this technology really skyrocket, or worse, not watching the roadblocks that might stop the technology dead in its tracks. So we encourage both business and technical people to work together to decide on where the right place is to indicate the velocity and position in time for any particular technology. Our second pro tip, undertake this task in small increments of time. Don't try and cram it all into one day and forget about it. The idea here is establish a point in time, keep your eye peeled, watch for data, be aware of it. We call it keep your attention up or keep your antenna up. And you'll find that when you're aware of the velocity and you're looking for the velocity, you might find that data is all around you and there might be new information every single day. So the key is pay attention on a daily basis, update your velocity index, and don't hesitate to move that marker if new information comes in. Pro tip number 3, don't overanalyze. The goal isn't to get the velocity index perfect. The goal is to improve the collaboration with colleagues, and that perhaps is more valuable than the data itself. Develop a small team where you and your technology partner, if you're in business, or your business partner, if you're in technology, work together, notify each other if something happens. If you're on the technology side and you realize that one of the roadblocks is about to come down, perhaps there's a breakthrough in the ability to charge batteries at a faster rate, or perhaps the storage capacity of batteries is about to increase it because of a breakthrough at some research lab. You want to inform your business partner that the velocity is about to increase. Or on the business side, you might find that you notice that the return on investment just isn't there. As much as we've tried to put batteries in place, the cost to put the battery in compared to the cost of an internal combustion engine is becoming a roadblock and the velocity is stopping. And you might advise your technical people that there's a cost issue that they might want to look into or work on. So this collaboration back and forth is just as valuable, if not more valuable, than the data itself. Don't worry about getting the velocity index perfect. Don't worry about getting it right. Keep that collaboration up with your team. And the data is not static. So our fourth pro tip is Industry 4.0 is an indication of technologies that change on a rapid basis. We would even say on a daily basis. Earlier, I used the example of LED lights starting in the 60s and finally reaching common implementation and maturity level now. Things move much faster than that. It no longer takes 40 years or 50 years for technology to go from invention to marketplace. We are now talking about years or months, even in some cases. So be vigilant for new developments. Changes happen rapidly and they are exponentially occurring all around us. And our final pro tip, if you have questions, please ask. That's what we're here for. And we wanted to help make this Velocity Index a very useful tool for your organization. And we hope this tutorial has helped you. We look forward to see your results.